I'm going to describe you the protocol SSL, Secure Socket Layer. Secure Socket Layer SSL and its newer version Transport Layer Security TLS are cryptographic protocol that provides security on the internet. SSL is used in every browser worldwide to provide HTTPS functionality. The latest version is TLS version 1.2 while the upcoming TLS version 1.3 is still in the draft stage. SSL TLS provide an authentication and data encryption between servers, machines and applications operating over a network. SSL runs above the transport layer, the network layer, which is responsible for the transport of data between process and the routing of network traffic over a network between client and server respectively, and the below application layer protocols such as HTTP and the simple main transport protocol. When considering the objectives of SSL, data is protected from tampering. Data privacy is ensured through a series of protocols, including the SSL recording protocol, SSL handshake protocol, SSL change cypherspec protocol, and SSL alert protocol, and also specifies processes for exchanging cryptographic materials such as SSL certificates for authentication, web servers, public keys for authentication of transmitted data, and private keys for session encryption. SSL includes two sub-protocols, record protocol, handshake protocol. The record protocol defines how communicating hosts exchange data using SSL, including specification for how data is to be prepared for transmission and how it is to be verified. Let's talk about handshake protocol. When they establish the SSL connection between client and servers, the first step, SSL client sends client hello message that lists cryptographic information such as the version of SSL, client order of preference, and the cipher suite supported by the client. Second step, SSL server responds with client hello contains with ciphersuite chosen by the server from the list provided by the client, the session ID, and another random string. The server also sends digital certificate if the server requires a digital certificate for client authentication. The server sends a client certificate request. In third step, the client verifies the server a digital certificate. In fourth step, client sends the random byte string that enables both the client and the server to compute the secret key to be used for encrypting subsequent message data. The random byte string is self-encrypted with the server's public key. In fifth step, if server sends a client certificate request, the client sends a random byte string encrypted with the client's private key together with the client digital certificate. In sixth step, server verifies the client certificate. In seventh step, client sends a server a finished message when handshake is complete. In eighth step, server sends the client a finished message when handshake is complete. In ninth step, in this session, the server and client can exchange messages that are symmetrically encrypted with the shared secret key. Then let's see the handshake using Wireshark. Wireshark is a packet analyzing software. Then let's see the SSL protocol behavior. First, look at my host IP address from command prompt. It is 10.0.0.79. My local browser is the client and the server is Amazon server, and I am going to open Wireshark software to analyze SSL protocol. There are many interfaces. I use Wi-Fi, so I select Wi-Fi interface. Then let's go to e-commerce website www.amazon.com. Look at this icon, click on this You can see the secure connection. Connection is secure. That is because SSL protocol. Then let's go to Wireshark. You can see the packets. You can see the packets behaviors from this software. Let's capture some packets and filter SSL. Here you can see client hello, handshake protocol. Let's go through the client hello. Here you can see source IP address and the destination IP address. This is the IP address of my host and the Amazon server IP address. In client hello, this is the frame. Encapsulation type Ethernet 1, arrival time and interface ID, frame number 285, frame length 571 bytes. And Ethernet source to destination, Ethernet protocol version 4, source IP address and destination IP address, and total length identification, protocol TCP, header checksum, source and destination, transmission control protocol, source port and destination port, sequences number, flag, window size, and transport layer security. Handshake protocol client hello, content type handshake, version of the client SSL TSL 1.0, length 512, handshake protocol client hello, handshake type client hello, length 508, version TLS. This is the under random. The session ID is length 32. This is the session ID. Cybersuit length 34. There are 17 cybersuits. Cybersuits mean encrypted algorithm. When clients send to 7 these encrypted algorithm to server, select one algorithm to communicate with client. Let's go through the server hello. This is source is the server and the destination is the client. Here frame Ethernet source to destination, Internet protocol version 4, source to destination, transmission control protocol, source port 443, destination is 51325, and here handshake protocol server hello, client type, content type handshake, version TLS 1.2, length 78, handshake protocol server hello, handshake type server hello, length 74, version under the random, session ID length 0, cybersuits. This is a cybersuit that serve selected encrypted algorithm. This is the comprehension method, and this is the certificate. Under the certificate, here are reasonable TCP segment in certificate. This is transport layer security. Handshake protocol certificate, content type handshake, version TLS 1.2, length 4138, handshake protocol certificate, handshake certificate, and certificate length 4131, and certificate length, this is the certificate, and the length. This is the certificate state, server key exchange and server hello done. Transport layer security, handshake certificate state, content type handshake, version TLS 1.2, length 479, handshake protocol certificate state, handshake type certificate states, length 475, and this is OCP response, length 471. OCP response is successful, and transport layer security and handshake protocol server key exchange, content key handshake, version TLS 1.7 handshake protocol server key exchange, and handshake type server key exchange 12, length 3 to 9. This is Diffie-Hellman server parameter, and under the curve type and name curve, public key length 65. This is the public key, and signature algorithm length, signature length 256. Signature, this is the signature. And server hello done. Under the server hello done, content type handshake and version TLS 1.2, length 4. Handshake protocol server hello done. Handshake type server hello done. When the server hello done means, then client verify that the certificate that sent by the server is valid. Client key exchange, change cipherspec, encrypted handshake message. Handshake protocol, client key exchange, content type handshake, change cipherspec protocol, content type change cipherspec, and handshake protocol, the content type handshake, new session ticket, change cipherspec, encrypted handshake message, and handshake protocol, new session ticket, content type handshake, change cipherspec protocol, change cipherspec, content type change cipherspec, and encrypted handshake message, content type handshake, and handshake protocol, encrypted handshake message. Then this is, after that, this is the application data, and after that data is encrypted and communicate client and destination. I think you can get an idea about the handshake protocol in SSL protocol. Thanks for watching.